In section 16.3, we're going to learn about barcodes. Barcodes go hand in hand with identification numbers, and identification numbers are often represented by barcodes. When you buy a packaged product at the store, it will have a barcode that represents the UPC code, and this barcode is scanned at the checkout counter. The barcode consists of bars and spaces, and the computer reads it by passing a beam of light over the barcode. The dark bars reflect back very little of the light, while the light spaces reflect back a lot of the light so that the computer can see the bars and spaces. So as I said, a barcode is a series of dark bars and light spaces that represent characters. So these characters can be numbers, letters, or other symbols. We're just going to be looking at numbers. Any system that represents data with only two symbols is called a binary code, and usually when you think of binary code, you think of a code that uses just zeros and ones. In this section, we'll look specifically at two different ways that barcodes are interpreted as binary codes. First, we'll look at a barcode system used by the Postal Service, and then we'll look at the UPC barcode system. So this is the zip code barcoding system. This is a simple barcode system called the PostNet code, which is used by the Postal Service and is commonly found on business reply forms or other types of bulk mail. The PostNet code represents the zip +4 code plus a 10th check digit using a series of long and short bars. So we'll talk about the check digit later. We saw in the last section that the zip +4 code itself does not include a check digit. So when we're translating to the PostNet code, a check digit is added on. You can think of the short bars in the PostNet code as zeros and the long bars as ones. So this is how it is interpreted as a binary code. Down here at the bottom of the slide, I've got a picture of a PostNet code. Notice that for each short bar in the barcode, there's a 0 in the binary code, and for each long bar, there's a 1. So we see that there are 52 vertical bars here, either long or short. There are long bars at the beginning and the end of the barcode, and these are called guard bars. They don't encode any information, they just kind of encapsulate the rest of the barcode. Inside the guard bars, we have blocks of 5 bars, and each block represents a single digit of the zip +4 code or the check digit. So let's look at how those blocks work. Each block has 3 short bars and 2 long bars, and there are exactly 10 possible patterns of this type with 3 short bars and 2 long bars. Because we have this pattern, it's easy to catch mistakes where just one bar of a block is printed incorrectly. You're either going to have too many long bars or too many short bars if one of the bars is printed incorrectly. And here I've got a chart with the pattern for each digit. So the digit 1 is represented by 3 short bars followed by 2 long bars. You can see that there's a different pattern for each digit all the way up to 0, which is represented by 2 long bars followed by 3 short bars. So now let's go back and talk a little bit about the check digit for this PostNet code. The check digit is chosen so that the sum of the 9 digits of the zip +4 code plus the 10th check digit is evenly divisible by 10. So this is a familiar system for checking. So we label the digits of the PostNet code as A1 through A10. Then the rule here is that the sum A1 plus A2 plus A3 all the way up to A10 should end with a 0, so be evenly divisible by 10. Let's look at an example of this. So this is a Colloy PostNet code. The zip +4 code for Bob's Mini Mart is 28723-6991, and we want to find the check digit for the postnet code and write the barcode for the postnet code. So I've rewritten my rule here. So I can fill in my numbers A1 through A9, and then I have to figure out what A10 is. So if I put those into my rule, I'm just going to add up the digits of my zip code: 2 plus 8 plus 7 plus 2 plus 3 plus 6 plus 9 plus 9 plus 1, and this plus my check digit A10 should be evenly divisible by 10 or end with a 0. So if I add up the digits of my zip code, that's going to give me 47, so this is equal to 47 plus A10. Now I want this sum to end in a 0, so the next highest number ending in 0 is 50. I'm going to set 50 equal to 47 plus A10. Then I can subtract 47 from each side, and that will tell me that A10 is equal to 3. So my check digit for the postnet code should be 3, and my postnet code is going to be my zip code 28723-6991 with my check digit on the end -3. So now I've got my code, and I want to write the barcode for this. So I've copied the code over here to the bottom, and I've got my table that tells me how to write each digit as a barcode, and all I need to do is find my digits up in this chart and then write the appropriate barcode in each one of these boxes. And I've got my guard bars already on the end here. So for 2, I'm going to have 2 short bars, a long bar, a short bar, and another long bar. For 8, I'll have long, short, short, long, short. 7 will be a long bar, 3 short bars, and then another long bar. 2, I just have to recopy what I already did: 2 short bars, a long bar, a short bar, and another long bar. 3 is going to be 2 short bars. Oops, put those closer together. 2 short bars, 2 long bars, and 1 short bar. 6 is going to be short, 2 long, and then 2 short. 9 is long, short, short, and I've got another 9 here. 1 is 3 shorts followed by 2 longs, and then 3 is going to be 2 shorts, long, short, long. So that is my postnet barcode for that zip code. Now let's take a look at a different type of an example. Here we've got a postnet code that has been typed incorrectly because the 6th block has only 1 long bar. So let's try to figure out what that digit X should be. So to do that, I'm going to use my rule again. So let's look at what this sum is. I'm just going to add up all of these digits from my postnet code. So I'll have 3 plus 0 plus 7 plus 2 plus 2 plus my unknown number X plus 9 plus 0 plus 1 plus 7. And then if I add up everything except for the X, that's going to give me 31. So this is equal to 31 plus X. Now to follow my rule, I want this sum to end with a 0, and the next number ending with 0 is 40. So I'm going to set 40 equal to 31 plus X. And if I subtract 31 from each side, that's going to tell me that X is equal to 9. So my incorrect number here should be a 9, and the barcode for that is going to be long, short, short. So the second long bar was printed as a short bar. In May 2011, the post office actually switched over to a new barcode system. The postnet code was replaced by the Intelligent Mail barcode. This new barcode converts 31 digits of data into 65 vertical bars that encode the type of service, the mail owner, a unique serial number that allows the user to track the letter, and the delivery zip codes. There's a lot more information contained in this new code. The new code also uses bars of 3 lengths and multiple levels instead of just the 2 different types of bars, so this is no longer binary because we have more than 2 symbols. And you can see in this example of the intelligent mail barcode at the bottom that we've got medium length bars, long bars, and short bars, and that the medium length bars either occur at the top or the bottom of the code. Next, we're going to look at the UPC barcode. And this barcode translates the 12-digit UPC identification number into bars that can be read quickly by a scanner. Each digit of the UPC code is represented by a space divided into 7 modules of equal length. So here in my image you can see that each character has a space that's divided into 7 smaller spaces, and then those are either colored or left blank. How the 7 modules are filled depends on the digit being represented, so they'll be different for each digit. There are always going to be 2 light spaces and 2 dark bars of various thicknesses. So for my first character here, I've got a 1 module light space followed by a 1 module dark bar, then another 1 module light space, and a 4 module dark bar. The second character has a 3 module light space, a 2 module dark bar, a 1 module light space, and a 1 module dark bar. So here's a picture of a whole UPC barcode. The UPC code also has guard bar patterns on each end, and in this case they consist of 2 long bars, 1 module thick, separated by a light space, 1 module thick. So you can see the guard bars on either end here. Now, UPC barcodes are much harder to read or to draw without the help of a computer, so we'll just focus on the idea of how they work. There's also a center bar pattern which separates the 5-digit manufacturer's number from the 5-digit product number. So you can see that center bar pattern here, which is just 5 dark lines. And this is a binary code because we can think of the dark bars as being represented by a series of 1s, 1, 1 for each module of thickness. And the light spaces can be represented by a series of 0s, 1, 0 for each module thickness of the light space. So in our example here, so we have a 0 for each module of light space and 1 for each bar. So my binary code here would be 0, 1, 0, 1, 1, 1, 1. So that tells me I've got a 1 module light space, a 1 module dark bar, a 1 module light space, and then a 4 module dark bar. And then for my second character, I'm going to have 3 zeros, 2 1s, 1 0, and 1 1. So how does this work in practice? Well, it might seem like the scanner wouldn't be able to tell if the UPC barcode was upside down or right side up when it was scanned, but that is built into the barcode, and to make it easy to tell, different codes are used for the manufacturer's number and for the product number. So here I've got a chart. You can see that each digit has a different binary code for the manufacturer's number and for the product number. And there are some patterns to these binary codes. Each manufacturer's number has an odd number of 1s, while each product number has an even number of 1s. Also, the product number can be obtained from the manufacturer's number by swapping the zeros and the ones. So here for 0, I've got 3 zeros to start with for the manufacturer's number. Then the product number starts with 3 ones. Then I've got 2 ones here and 2 zeros over here in the product number, and a 0 and a 1 in the manufacturer's number, which flips over to a 1 and a 0 in the product number. So that is a summary of how the UPC barcode works. Now let's look at a few fun applications of barcodes. So an interesting example is the entomologist Stephen Buckman glued barcode labels to the backs of 100 bees and placed a laser scanner above the hive of the bees. So in the past, researchers had marked bees with paint or tags to try and track their movements, but this method allowed Buckman to track their movements without a human observer. He just had the scanner above the hive. In 2003, a method of barcoding genetic information about animal species was introduced. And this barcoding method provides a convenient, inexpensive way to identify species. A more recent innovation in barcoding is the QR code or quick response code. You may have seen these types of code around. The code consists of black modules, which are square dots, arranged in a square grid on a white background. And this type of code can contain more information than a standard UPC barcode. That finishes up this section, things you should know. You should be able to convert a given zip code to its corresponding barcode and vice versa. You should also understand how UPC codes are translated into barcodes.